Good morning. Today I will continue with the modern periodic table. In the modern periodic table, there are 18 columns and 7 rows. So today I will teach you about group wise and period wise electronic configuration. So first, period wise electronic configuration. Each period number indicates the number of the shell in which the outermost electron is filled. For example, let's begin with the first period. When the period is the first period, there is only one subshell which is called S, and in the S subshell only two electrons can be accommodated. That's why there are only two elements in the first period, hydrogen and helium. Next, in the second period, there are two subshells because the second period is constituted by the filling of the electrons in the second shell. And in the second shell, there are two subshells, S and P, where S can accommodate 2 electrons and P can accommodate 6 electrons. So thus, there are 8 elements in the second period, beginning from lithium and ending at neon. The third period is also similar to the second period, where there are 8 elements, because in the third period filling of electrons takes place in the third shell, and in the third shell, just like you have in the second shell, there are only 2 subshells, S and P, and once again having 8 electrons. So there are 8 elements beginning from sodium and ending at argon. Next, fourth period. Fourth period is constituted by the filling of electrons in the fourth shell, and in the fourth shell along with S and P there is also another subshell called D, where 10 electrons can be accommodated. So total 18 electrons. That's why we have 18 elements in the fourth period, beginning from calcium and ending at zinc. The fifth period is also similar to the fourth period, having 18 elements. From the sixth period onwards, it is the filling of the sixth shell, and sixth shell onwards there is one more subshell, F, where 14 electrons are possible. So altogether 32 electrons, which means there are 32 elements in the sixth period. The seventh period is also similar to the sixth period, having 32 elements because of the filling of electrons in S, P, D and F subshell. Once again, S can accommodate 2 electrons, P 6 electrons, D 10 electrons and F 14 electrons. Thus, the entire periodic table can be classified into 4 blocks, S block, P block, D block and F block, based on the outermost electron being accommodated in which subshell. In S block, there are 2 groups, group 1 and group 2. In the D block, you start from group 3 and end at group 12 because there are 10 groups. In the P block, you have 6 groups. So you start from group 13 and end at 18. The F block is 2 rows at the extreme bottom of the periodic table. Now, let me tell you about the group-wise electronic configuration. As we began earlier, elements in the same group have same properties because they have same outer electronic configuration. Let us take the example of group 1, where the first element is lithium, having atomic number 3. So the electronic configuration is 1s2, 2s1. Next element below lithium, sodium, having atomic number 11. Electronic configuration 1s2, 2s2, 2p6, 3s1. So you can see the outermost configuration is common, S1. Next you will have the element potassium, where the element will have outer electronic configuration 4s1. So since the outermost electronic configuration is same, elements in the same group have same properties. As I told you, the entire periodic table can be classified into 4 blocks, S, P, D and F, and each block have their own set of properties. Now, with the help of the atomic number, we can find out the element belongs to which period, which group and which block of the periodic table. I have shown you the example of an element having atomic number 17. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. You can count the number on top. S2 plus 2, 4. 4 plus 6 will give you 10. 10 plus 2 will give you 12. And 12 plus 5 will give you 17. So the outermost configuration is 3p5. Since the outermost configuration is 3p5, the period number is 3. The block is P and you have P5. I've told you earlier, P block means group 13 to group 18. So P5 belongs to group 17 because P1 will be 13 and so on. P1 13, P2 14, P3 15, P4, P5 and P6. P5 belongs to group 17 in the periodic table. IUPAC has given a set of rules for writing down the name of elements having atomic number more than 100. Accordingly, as you can see, there are 3 columns. The first column is for the digit, the second column is for the name, and the third is a symbol. 0 is written as nil, N-I-L, having symbol N. 1, un, having symbol U. 2, symbol B, written as B-I. 3, T-R-I-T. 4, quad, Q-U-A-D, symbol Q. 5, pent, P-E-N-T, symbol P. 6, hex, symbol H. 7, sept, S-E-P-T, symbol is S. 8, oct, O-C-T, symbol is O. 9, E-N-N, N, symbol is E. Supposing you want to write down the name of an element having atomic number 120. From the above column you had seen 1 is un, U-N, 2 is bi, B-I, and 0 is nil, N-I-L. So the name of the element will be U-N-B-I-N-I-L-I-U-M and the symbol will be U-B-N. I-U-M is supposed to be written at the end of each element. Similarly, 110 is written as U-N-U-N-N-I-L-I-U-M.